Hey everyone, welcome back to another video. And today's video, we are going to be deriving the formula to find the square root of a complex number. Now this is going to be a cool video. We're not going to use De Moivre's theorem, we're going to use the algebraic method. Now, let's start today's video. Okay, so now, you may know that the square root of a complex number is also equal to another complex number, right? So what we could do is, we're going to let this complex number a plus bi equal another complex number. Let's call it c plus di. Okay, so in this equation we have two. On the LHS we have a radical complex number. On the RHS we have a simple complex numbers. Okay, now you might be thinking, okay, so look, our goal, let me write the goal here. So basically, our goal, find CD, okay? So basically, our goal here is to find CD, because when we find C and D, we can plug this into the standard form of the complex number, and then look at the answer. So you might be thinking, what's the first step to do this? Correct, squaring both sides. So let's go ahead. So look, if I square both sides, if I square this side, the square and the radical cancel out. So I just get a plus bi is equal to c plus di whole squared. I'll write in bracket squaring both sides. Okay? So now that we've done this, we have to expand this. So c plus di whole squared, we can work this out. C plus di into c plus di. This will just be c squared plus c di plus, look, c here, then another c here, then the c. Okay, so look, c squared plus c di. Okay, look, okay, so c squared plus c di plus c di again. Now why c di? Because look, first c into c. Look, actually what we're doing is we're breaking this down. And if you want to think about this in a better way, rather than distributing, you can write this as this: c into c plus di plus di into c plus di. But basically splitting it up into two parts. Now you can simplify this, distribute this and that, here this and that. Okay, so c into c is c squared, c into di is c di, and then here di into c is dic, or you can write as c di because multiplication is associated, so I'm just going to write this as c di. Then plus the whole square of di. Okay, so look, after we're done distributing, what's left is to simplify this. We can write this as 1 CDI plus 1 CDI is 2 CDI. So let's write this as 2 CDI. Great. Now you just have to simplify this. Actually, look, this will just be d squared into I squared, which is negative 1 into d squared, because I squared is negative 1. So this should just be negative d squared. Okay? So this would just be negative d squared. And we can also shift this to the other side, c squared negative d squared plus 2 CDI. 2 CDI. Because actually when we have three terms, it doesn't matter if we're adding or subtracting, we can shift the order. So this is also correct, because I want to group the real and imaginary parts. You're going to see why. Okay? So now that we got that this is the solution to the c squared minus d squared plus 2c di. Okay, so we don't need the bracket now. Okay, so this is the solution to this. Let's write that there. Okay, so c plus c squared minus d squared plus 2di. So c squared, okay, c squared minus d squared plus 2c di. Okay? Alright, amazing. Okay, so now let's continue from here. Okay, now now what I'm going to do is, if you remember the rule of equality numbers, the equality of complex numbers, if we have two complex numbers, a plus bi equal to some other complex number, okay, let's say x plus y. This is an example. So this would mean that the real parts are equal. A is equal to x, and the imaginary parts, b is equal to y. Now we don't have to write y, because we can write bi equals yi, but if you divide y on both sides, it gets cancelled out, because I is the same on both sides. So this is the condition. Now let's apply it there. Okay? So if we apply it here, we're gonna get, so we're gonna have a system of equations, okay? This is a system of equations basically. First, c squared minus d squared equals a, correct. And in here we have b equals 2cd, because the I just cancels out both sides if we divide both sides with an I. Alright? When we let the imaginary parts equal each other. Great. So what's left is we just have to solve this equation. This system of equations. So I'm going to do a substitution method. Now, if you don't know what a substitution method is, basically what I'm going to do is I'm going to substitute one value of a variable from one equation to another equation. Let me show you. For example, let's take equation 2. Okay? So I'm going to call this 1. I'm going to call this 2. Okay? Yeah. So look. Suppose in this equation, I want to rewrite this in terms of d. Okay? So d would be b upon 2c. And yes, we have a restriction. Okay? So look, suppose I get this. And remember one thing, c cannot be 0. Let's write that here. C is not equal to 0. Okay? Okay? Now what I'm going to do is, this d, I'm just going to substitute this d from this equation to the other equation. Got it? So from equation 1, okay? So in equation 1, let's draw an arrow here. So now, this is just c squared minus b upon 2c squared equal a. Now first simplify this. This would just be c squared minus b squared upon 4c squared equals a. Got it? Okay. Now what I'm going to do is, we're going to combine the denominators. Okay? So basically in this, what I'm going to do is, I'm just going to multiply, making c squared minus b squared upon 4c squared. I'm just going to multiply this of c squared by 4c squared. Okay, so when I multiply it, the numerator denominator by 4c squared, assuming c is not equal to 0, okay, so what I get is, the denominator will be 4c squared, okay, and the numerator will be 4c squared into c squared, will be 4 times c to the power of 4, okay, so this would just be a quartic, basically, the 4c to the 4. Now let's combine, okay, so 4c4, yeah, 4c4 minus b squared upon 4c squared. Okay? is equal to A. Okay? So this is a refined equation that we get when we simplify this. So now I'm just going to erase this. So now we got the equation. Alright, well, let's write this equation here. We have 4c to the fourth minus b squared upon 4c squared equals a. Alright, let's see how to solve this. So look, first we're going to do cross multiplication. So we're going to multiply from here. We get, see, 4, multiply anything by 1 is just itself, so we get 4c to the fourth minus b squared equals, now we're going to cross multiply 4c squared and a. This is cross multiplication. So this will be 4c squared a. So now I'm seeing something. I'm basically seeing a quadratic equation, but with like multiple variables. So what do I do here? Don't worry. You can figure this out. It's not that simple. See, look. What was our goal? Our goal is to simply find CD. Well, actually, when we get the result, we won't see any CD. But the goal is just to see, because C and D will be having will be in terms of like A and B like stuff. So like you'll see in the end. Okay, so now we have this. Okay, so now let's erase this, and now we have a quadratic equation. Minus b squared equals 4c squared a. Okay, you know what I'm gonna do? I'm gonna make a quadratic equation in terms of C. You know what the best part is? This will also be a depressed quadratic, and we can just do the substitution. Let me show you. Look in here, common term, c to the fourth, then c squared. And we can just write the 4a as we can let 4a be a coefficient. Sound good? And b squared will just be another coefficient. Got it? So they'll write it something like this. It'll be something like this. So it will be like, see, 4 into, I'll put brackets so you can understand better. 4 into c to the fourth minus, so look, when we move this to the other side, we get minus b squared minus 4c squared a. Now, I told you we can shift the order, so I'm going to shift the order. I'm going to write this as minus 4a into c squared minus b squared. Now just examine this. This is all the same thing. I have a bracket so you can understand. So just assume, look, in this case, and we can just say like A, B, R are constants. Okay? So look, in this case, we have assumed A and B are constants. Because this quadratic, like sort of, I guess, because now we have a quadratic equation in terms of C. So if you want to know how to solve this, let's see. Look, don't freak out. We don't have to use the quadratic formula and all that, because guess what? We can use the substitution method. So we're gonna let c squared. So let c squared equals y. This is substitution. Okay. So when I substitute this, okay, let me just write it here. 4c4 minus 4a c squared minus b squared equals 0. Okay, and now remember, in this case, we're going to be, at first, when we take the square root on something, if we have to, in some case, we're only going to assume the principal square root. In the end, if you want to have both the roots, you can just put a plus or minus sign after, like, before the expression, to the left side. Okay, so look, now we have this equation from equation 1. We have a quadratic. Okay, so now So now what we're gonna do is, I'm just gonna like, basically, I'm gonna do a substitution here. So what will this become? See, c squared is equal to y. So I can write this as 4y squared minus 4a y minus b squared equals 0. And we already established that a, b are constants. Look, because this is the same thing. We just let c squared equal y. So if you were to expand y squared, it would just be c to the 4th, and y would be c squared, and b squared is a constant. Got it? Okay, now we just have to solve this quadratic, and we can simply use the quadratic formula to solve this. Take a look. So look, this is in the form of ax plus, look, this is in the form of ax squared plus bx plus c, where all of these are negative. These two only. So look, basically, like, let me write it. I think, actually look, a is equal to what? 4. Okay, because 4 is the coefficient of y squared, the square term. Then we have b equal 4a, because 4 is a constant, as we established. Okay, we already know that. Now, c is equal to negative b squared, which is also a constant. So this is just to keep in mind the coefficients. Now we can just simply use the quadratic formula to find y. So y will be negative b. So actually look, so one more thing. This is b is equal to negative 4a. Now look, one more thing here. If b is negative 4a, then negative b will be positive 4a. So the formula is negative b plus or minus the square root of b squared minus 4ac upon 2a. I think you guys know that. So we just use that. So b squared, no, it's just negative b, which is 4a. The negatives cancel out. Then we put plus or minus. Now look, in this case, we're only going to consider the positive version. Keep this in mind. We're going to consider the positive version. For now, look, the thing is, actually, look, let me just basically, okay, let's first use the formula. So, negative b plus or minus the square root of b squared. The square root of b squared minus 4ac. That's a b squared, negative 4a squared. So negative 4 squared is 16. A squared is 16. A squared is a to the 2 is, this will be 16a squared. Minus 4ac. This is so 4. So 4 into a into c. 4 into 4, 16. 16 to negative b squared is negative 16b squared. But negative 4ac would be positive 16b squared, because the negative cancel out. Okay? Oh god. Okay? Good? Now 2a. 2a is just 8. Great. We got our solutions. This is our solution. Okay? So look, remember the substitution we did here? Well now, I just have to take the square root on both sides. So if I take the square root of c squared, it will be c. So basically, c will be equal to the square root of y. We want c. So c is basically the square root of y. So what I'm saying is, c, look, I think I should write this now, as I showed it, so I can write the solution for c. Okay. So now we have 4c to the 4 minus 4ac squared. Okay, good. Okay, now our solution is basically c is equal is equal to the square root, big square root of 4a plus or minus the square root of 16a squared plus 16b squared upon 8. Okay, so are we done yet? Not quite yet. We're not done yet though. So look, now what we're gonna do is we've done all the substitutions. We found C now. Now we're just gonna like kind of sort of simplify this expression. Then we're gonna substitute this into D. But look, we're not gonna take the square root of this. I'm just gonna break this down. We can write this as the square root of 4a upon C. I'm just breaking down the denominator. Plus or minus the square root of 16a squared upon 64 plus 16b squared upon, now why did I put 64? Because the square root of 64 is 8. So now I'm just gonna write 8 is squared to 64 so I can simplify what's inside here. Sure. Divide by 16, you get 1. Divide by 16, divide 64 by 16, you get 4. Awesome. So just 1, you get 4. So this just basically simplifies. And look, 4 upon 8, divide by 4, 1. Divide 8 by 4, you get 2. So this should just be the square root of a upon 2 plus or minus the square root of a squared plus b squared upon 4. Okay, but are we done yet? Not yet. We still have to simplify what's in here. Okay, so look. Basically, okay, so now this is C. We've simplified this expression and we got this. Amazing. Okay, now look. Okay, got it. So look, even though after doing all this, we're not done quite yet. Look, see what's inside here? I can write this. I'm gonna write it here. I can write this as the square root of a upon 2 plus or minus the square root of a squared plus b squared upon 2. Why? Because I'm taking the square root of the numerator and denominator. The square root of 4, the principal square root of 4 is 2. Okay? So this is what we get. So yeah, I know if you want, we can combine this. So we can just take whole denominator 2. Okay? So, alright, so it'll just be a plus or minus this, a plus or minus that upon 2. We combine the denominator. Good. Now our final value for a is the square root of a plus or minus the square root of a squared plus b squared upon 2. Good. We've done all this. Alrighty. So now what I'm gonna do is alright. Good. So we've done all this. Actually, now what's left is we're gonna substitute this into D. Now what was D? What is D? So I think I can erase this quadratic equation now because I already solved it. Alright. So what is D? Look, D was basically B. B is unknown. But as I said, the answers will have A, B. Okay? C and D are just the other variables we're using. B upon 2 into C. 2 base C is this. So look, now 2 into the square root of a plus or minus the square root of a squared plus b squared upon 2. Good. Okay, good. So now we have Okay, wait. Let me put the denominator b. Wait. This is a fraction denominator symbol. Okay, so I just have this. C is equal to that, and D is equal to b upon 2 into C, which is C, a plus the square of, that. Okay, so now all that's left is we're going to plug this into that. Okay, so I'm just going to erase all this we have here, because now we have found our roots. And we can write the general form for a complex number. So when you're finding a complex number, you can use this method. Okay? Okay? Alright, so yeah, let's get to the answer. Alright guys, so take a look here. And then we put C plus DI. We accomplished our goal. Yay! But look at here. We have the principal square root of a plus bi is equal to the square root of a plus or minus the square root of a squared plus b squared upon 2. That's C. Plus b upon 2 into a. So look, b upon 2 into the square root of a plus or minus the square root of a squared plus b squared upon 2. That's basically the whole expression, which is equal to a. This, which is c. So b upon 2 into c. Okay, and we multiplied this whole expression by which imaginary unit? I. Yeah. Okay, so basically, this is the answer. But look, take a careful look here. The principal square root, we're actually gonna have to do some adjustments here. Now, what I mean by this, remove the minus, make this a plus. Plus, same here, a plus. Okay, then this is the principal square root. This is the principal square root. Acha. Now, why am I doing this? See, in the principal square root, we have one solution. Make sense? That's why we're doing this. That's why we're doing that. But because the thing is, wait, where's my pen? Oh, sorry. Okay, yes, good. So anyways, this is actually, if you guys would, but look, suppose we put plus or minus here. Then we will also put plus or minus here. Okay, of the whole bracket. Okay, but in this case, we're not doing that actually. We're just finding the principal square root. But of course, if you do want to find the actual both of the square roots, then you're gonna have to put the plus minus sign here. You don't put it in here, because the thing is, our main purpose was to find the principal square root. Okay, so that's why. Suppose if you have to, so look, I'll also put the formula. If you want to find the positive or negative version, only in blue pen, okay? So plus or minus. Oh damn. Alright, so plus or minus. Nope. Okay, so I'll just do that with this. So a plus, so plus or minus the square root of a plus bi is equal to plus or minus. Okay, just put it plus or minus on both sides. That's what's happening. It's nothing special. Okay, it's not anything special basically. Okay guys, so take a look. If you want to find that both square roots plus or minus the square root of a plus bi, then you just have to put the plus or minus. You don't have to distribute it, just put plus or minus, put a bracket of the expression, and when you simplify this whole thing, just add the plus or minus sign at the end. So yeah, I guess this is the square roots of the complex number. If you enjoyed the video, like and subscribe. Give it a tap, and also, if you have enjoyed the video, please like and subscribe. And I'm excited to see what you guys got next, because the thing is, actually, I haven't been uploading for a while because the thing is, I was kind of busy with life, so, but now, hey, I'm free guys, so this is our answer. Right here. We have an answer. This is how you verify it. You can, if you want, you can just, to find the square root of complex number, you can just plug it into this, or you can just use the algebraic method that I use in today's video. So, yeah, with that being said, bye. Bye. So just a quick thing, this expression, I has been multiplied with this term, the one with the b upon 2, because this is the imaginary term, okay? Yeah, so I guess that's all, basically. That's all I have to say. If you got any suggestions in the comment sections, let me know. And without further ado, peace out. Yeah.